Today we start chapter number 3, which is about trigonometric functions. You already studied in probably 9th and 10th both the standards. Now here in 11th and 12th also we have concept of Trigo functions. You will realize here approach is little bit different than the earlier standards. The first thing is just recall what is trigonometry. So you know that trigonometry is a study of sides and angles of a triangle. Basically, you will realize it has a number of applications in physics and chemistry also. You will see once we start learning. Now here the first thing which we want to start, that is about angles. You know what is an angle, you know from geometry. So I'll consider a ray here. This is the beginning position of the ray, OA. So this is sometimes called initial ray or initial side of a ray. Then I'll rotate this ray in this anti-clockwise direction. Suppose this is the final position of the ray. Rotating this ray A in this anti-clockwise direction. Suppose this is point B. So this is a final or terminal position or terminal side. Then this is nothing but the measure of rotation, this much. This is a measure of rotation. This is a measure of rotation and is called measure of angle. Is called measure of the angle. So measure of the angle is as good as a measure of the rotation of a ray from this position to this position. Here it is an anti-clockwise direction, remember. If I have like this, for example, this is the initial side, for example, A, O, I may rotate this ray in clockwise direction like this, in this direction. Then this is also measure of rotation. This is also known as measure of an angle here. But when it is in clockwise direction, then here negative angle is used. Negative angle is used. And when it is in anti-clockwise direction like this, then here positive angle symbol is used. Positive angle. So positive angle means you are moving in anti-clockwise direction. Negative angle means you are moving in clockwise direction. If I have this, for example, if I take this as a starting ray, initial ray in the beginning, now I'll move in this direction. I start from this, I complete one rotation here, one revolution, I come to the same position. So here this is B, for example. This is initial position. This is a final position. This is one complete revolution. This is one complete revolution. So this is a positive angle with one complete revolution. Now what we do, here from starting to the ending, we consider 3/60th part of this, that is 1 upon 360, that is 3/60th part of one rotation, or you can say 1 revolution, 1 rotation or 1 revolution. 3/60th part of 1 rotation or revolution is called measure of 1 degree. Is called measure of 1. We put small circle. This is read as 1 degree. 1 degree. So here degree is one measurement of unit of measurement of the angle. Okay. So what is the degree measurement of an angle? This is degree is just one unit of measurement of the angle. Like if you have length, you can measure in meter, centimeter, kilometer. Your angle is measured in form of degree. What is 1 degree? It is nothing but 3/60th part of 1 rotation or 1 revolution. So if this is 1 revolution, you take 3/60th part, that is 1/360 of 1 rotation. So here if I show like this, is a starting ray here. If I complete 1 rotation now, so as per definition this become 360 degree. Remember, the one part of this complete rotation is called 1 degree. Remember, if I have, so here theta, the measure of the angle is 360 degree. If this is, for example, starting ray, from this, if I take this much rotation only, half rotation, this is B, starting ray, ending ray, that is final position, this much. This is called 180 degree. Remember, so this measure of an angle is nothing but 180 degree. If I have one more, this is 1, 2. If I take this as a starting, for example, like this only, the half of this much only, so this is called 90 degree. You know, this is O, beginning, and this is ending position, final position B. So this is 90 degree. So here measure of angle is 90 degree. Here measure of angle is 180 degree. Here measure of angle is 360 degree. If I take this as a, for example, initial ray, now I'll move in this direction like this. If I come to this position here, so this is half rotation, but it is in clockwise direction. So this is minus 180 degree. This is the third example. This is the fourth example, minus 180 degree. This is OA. If I take half of this rotation, this one is of course 90 degree, but we are moving in this direction. So this is minus 90 degree. Remember, when you move in clockwise direction, then negative angle should be used. When you move in anti-clockwise direction, then positive angle is used. Here you are moving in anti-clockwise direction, positive angle. You are moving in anti-clockwise direction, positive angle. If I show like this, for example, this is a starting ray OA. Now I'll start from this and I move in this direction. You know that this is a clockwise direction. Beginning, final position. So this is of course 360 degree, but we write minus 360 degree because you are moving in which direction? Clockwise direction. This was in anti-clockwise direction. If I take, this is O, here A. If I take first quadrant only, then this is 90. If I take half of this one, this is a final position. So roughly we call this as 45 degree. If I take this as a starting ray, and if I move in this direction here, like this, in this direction, so this is minus 45 degree. Negative sign indicates that you are moving in clockwise, you are moving in anti-clockwise direction. Now suppose here this is initial position. I'll start from this I'll complete one rotation here, so 360, and then again I'll do this much over here. After finishing one rotation here, I'll start from this here, one rotation, that is 360, and then this much only, this one, this is 90. So the total degree here, starting from here to here, if this is a final position, then this is nothing but 450 degree, but it is in anti-clockwise direction, so it is positive, right? This much total. Why 360 plus 90? Because you had completed one revolution and then first quadrant, this much. After completing this, it is one revolution means 360 degree, and then up to this it is 90, so it becomes total 450. If I take one more, like this is initial position here, I'll finished one rotation here 360 degree, and then again I'll come to this position here. So this is, for example, final position. So this is again 180. So total angle here from this to this will be the sum of these two, which is nothing but how much? 540. The sum of these two. Again I repeat, see, I have started with this initial position, complete one revolution here 360 degree, then again half revolution, that is 180 degree. So here angle theta is nothing but the 540 degree, starting from this initial to the final position. So this way we understand positive and negative degree measurement of an angle. Each of these are presented, that's called the degree measurement of an angle. Remember, small circle is used to present degree measurement of an angle. Remember, degree measurement of an angle. Now this is another unit for measurement of an angle, which is sometimes called radian measurement of an angle. And then finally we'll see what is relation between radian and degree measurement of an angle. So for this we consider a circle here. You know what is a circle? With radius equals to we fixed 1 unit here. We start with a circle with radius equals to 1 unit here. So in this case, if you consider circle with the radius equals to 1 unit, what will be the circumference? In general, circumference is nothing but the 2 pi r, that but here radius is 1 unit, so in this case the circumference is just 2 pi. Here r is 1, remember, 2 pi into 1, so it is just 2 pi. Circumference, it is this total arc length. If this is a circle, then starting from here, circumference means this arc length starting from here to this much. This arc length, it is called circumference, which is in general 2 pi r. But in our case, we have consider circle with radius equals to 1. So here r is 1. So this arc length is 2 pi. Remember, from this to this. Now, circle with radius equals to 1 is sometimes called unit circle. So we have considered here indirectly unit circle here. So like this, we have a circle here. You know that the radius of this circle is 1 unit here. So if this is a radius, so this is 1 unit. Now this arc length, for example, and this arc, let me take this as A, here this as B. If I join this with center, let me call O as a center. This is also 1 unit. This is the beginning, this is the ending, starting from this to this. So AB is arc here. If the length of this arc is 1 unit, repeat, if the length of arc equals to 1 unit, so this much, then we say that the angle subtended by this arc at the center is 1 radian. Then we say that angle subtended by the arc at the center is 1 radian. So here this angle, that is a measure of rotation from this to this. If this is 1 unit, then we say that this is nothing but the 1 radian here, remember, 1 radian. So this way we define. If this is, for example, now, so I hope this is clear to you. What do you mean by 1 radian measurement of an angle? That means the corresponding arc has length 1 unit. Or in another language, if this arc length of 1 unit subtend an angle with the center is nothing but the measure of 1 radian, remember. 1 radian, 1 unit of arc length. If I have a circle like this, if this is a center, this is the starting position. Suppose if I have this one, B, if this arc length is, for example, 3 unit, then the angle of rotation, we say that this is nothing but the 3 radian. 3 radian. So here we say that the angle subtended by this arc at the center is 3 unit because this arc length is 3. Now again I am moving in which direction? Anti-clockwise direction. So I wrote 3 radian positive. Here we are moving in which direction? Anti-clockwise. Now see this. If this is a circle, there is a center. Here we have A. Suppose this is B here. Now we are moving in clockwise direction, remember. There is a final position of this ray, radius. Now if this is 2 unit, for example, arc length, if this is 2 unit, then we say that this angle is nothing but the minus 2 radian. This minus sign indicates that you are moving in clockwise direction, remember. Okay, minus 2 radian, angle subtended by this arc with the center of the circle, because this arc length I have considered as 2 unit. So arc length equals to radian measurement of an angle. Arc length is 3, so radian measurement of an angle is 3 radian. Arc length is 1 unit, so radian measurement of an angle is 1 unit. Arc length equals to radian measurement of an angle. This is how we define radian. Now obviously if I start from here and if I take one complete rotation and I come to this finally, so that's what I'm trying to show you now. If this is a unit circle, remember, unit circle means radius equals to 1. This is a center, this is initial position or initial ray. Now I'll take one complete revolution and this is the final position, again here B. This was the initial position, this is the final. You have taken one complete revolution as I explained in degree measurement of an angle. Now what is the measurement of this angle in form of radian? So it is same as you find this total arc length, because radian measurement of an angle is as good as this total arc length. What is the total arc length of the unit circle? You know, 2 pi. So this one complete revolution becomes how much? 2 pi radian measurement of an angle. So when you take complete revolution in anti-clockwise direction, then this become 2 pi. I again repeat, I again emphasize why this is 2 pi radian, because you took one complete rotation. Now one complete rotation means you find the one complete rotation arc length, because you know radian measurement of an angle. Why this was 3? Because this arc length was 3. Why this is minus 2? Because this arc length is 2, but here you are going in clockwise direction. Why this was 1 radian? Because this arc length was 1. So when I take one complete rotation here, then why this is 2 pi radian? Because here the total arc length of one revolution, you know that it is 2 pi circumference. So we can say that this angle is nothing but the 2 pi radian. If I take this much only, now you can see if this is O, this is A, and this is B. If I take this much, this is half revolution. Now what about this arc length? You know that if the total is 2 pi, then this is a semicircle. So this arc length is how much? Half of this, pi radian. So this angle is also pi radian. So this is pi radian. So O, A, it is understood that you have a unit circle here. If I go up to this, then this would be nothing but this arc length. Now what about the measure of this arc length? Total is 2 pi. So half is pi. So this is pi by 2. So this measure of angle is nothing but the pi by 2 radian. If I have a unit circle here, that is a circle having radius 1 unit. This is O, this is A. If I move in this direction, this much, we want this much radian. Now this is nothing but one quadrant. If I take up to this portion, then this is pi radian, because total is 2 pi. This is a semicircle. Again the half of this, so this is pi by 2 radian. So this angle will be minus pi by 2 radian. Why? Because you are going in clockwise direction. If I take this one, O, A, you consider here circle. If I start from here and if I take up to this is half revolution. This is final position. Now what about this arc length? You know that total arc length for unit circle is 2 pi. So this arc length is pi. So this measure of an angle is nothing but the minus pi radian, because you are going in clockwise. Remember, if I would have taken this way, then it is just pi radian. Okay, now so you have two different units. One is degree and the other one is radian. Radian means in terms of pi, remember, radian, and the other one is degree. Degree measurement of an angle and radian measurement of an angle. We want to see how we'll connect them. So you already realized, or if I say here, if you recall, in a degree, this is OA. If I start from here and if I complete one revolution, this is nothing but the 360 degree. If I imagine this as a unit circle here, so what about this arc length? You know that for unit circle is 2 pi. So you can say that this angle is 2 pi radian. 2 pi radian. So this is a relation. 360 degree equals to 2 pi. When you write pi, that means it's a radian. No need to write every time radian. So this is a relation. 360 degree equals to 2 pi radian. So obviously you can say that 180 degree equals to pi radian. This is just beginning, that's why I'm emphasizing. Otherwise when you write pi, that means it terms of radian, remember. And when you write in form of degree, you need to put here small circle. You take half of this. If I do half, 90 degree, this is pi by 2 radian. Again, if I do half of this, so you have 45 degree, half of this, that is pi by 4. You take 4 over here, so you'll get this, pi by 4 radian. So 45 degree pi by 4. 30 degree if you recall. So I do by 3. So you can say that 30 degree is nothing but the pi by 6 radian. Now I'm not writing radian. When we write pi means it's in form of radian. 30 degree pi by 6. You take 6 over here. So 180 equals to pi. I want, for example, 60 degrees. So I'll do by 3. So 60 degrees is nothing but the pi by 3 radian. 60 degrees pi by 3. If I do double of this, you can say that 4 pi equals to 720 degree, this way. So these are the standard conversion, remember. This is a relation 180 degree equals to pi, 90 is pi by 2, 45 degrees pi by 4, 30 degrees pi by 6, 60 degrees pi by 3, 4 pi is 720. In 10th standard in 9th and 10th you were emphasizing on degree measurement of an angle. Now onwards we mainly use radian measurement of an angle, so we emphasize on pi, remember. So when I write 1 in angle, that means this considered as the radian. Pi means in form of number. So this is considered, 1 is considered as the 1 radian, remember. But when I write 1 like this, so this is 1 degree. So this is 1 degree, this is 1 radian. Both are different, remember. So from this you can say that 1 degree equals to pi by 180 radian. If I can write simply pi by 180, it is understood it is in form of radian. And if you do 3.14 by 180, here you can find the value. So this will be roughly 57 degree. You can verify by calculator. 3.14, yeah, 22 by 7 by 180. And here, I'm sorry, I forgot to mention, here we take 1 degree as 60 dash, that is 60 minutes. "60 minutes gives us 1 degree, which we denote by this. In same way, 1 minutes equals to, we take 60 seconds. So this is 60 seconds. 60th part of minute is called the second here, and 60th part of degree is called minute here. So 1 degree equals to 60 minutes, and here 1 minute equals to 60 seconds. We use this double dash, single dash. Now here if you see roughly pi by 180, you will get the 57 degree. And so if you do pi by 180 using calculator, you will get 0.01746 radian. This is the radian because it's a number, remember. 1 degree equals to this much, 0.01746. This is the radian measure, remember. And now I'll do reverse. I want 1 radius here, 1 radian here. So 1 radian equals to, I'll take 80 over here, 180. So 180 degree by pi. So if I do 180 by pi, and if I use this concept here, you will get here. So if you do 180 by pi, you will get the roughly 57 degree and 16 minutes. I'll tell you how we'll get this. We have such questions in exercises, you will see. It's like this. If I do 180, if I show here, if I do 180 by pi, here, let me show here. If you use calculator, you will get here 57 point. You'll get the 57.272727, something like this. Use calculator, you will realize. So this is 57 degree. Now after decimal point, so now next smaller unit. So which is the next smaller unit, which is minute. So it is 0.2727 roughly, if I take this much only. Now this is degree, I want to convert into minutes, so I'll multiply by 60. If you do this much, you will get the roughly 16 minutes here. Remember, after decimal point, this is 57 degree. After decimal point, you are converting into the next smaller unit. Now you have 0.2727 degree, but I want to convert into minutes. You know 1 degree equals to 60 minutes, so I'll write here 60. So we'll get the 0.2727 into 60, so we'll get the roughly 16 minutes. So we are getting this. So 1 radian is roughly 57 degree, remember. And here 1 degree is roughly this much radian. So if I have this one, now you imagine this is initial ray. If this is 1 unit, for example, if this is 1 unit arc length, then this is 1 radian measurement of an angle, and the same measurement of an angle if I write in form of degree, so it will be roughly 57 degree and 16 minutes. Remember, this is in form of degree and this is in form of radian. 1 radian is roughly this much, so you need to remember this. 1 radian is this. You can do by calculator simply 180 by pi. We have such questions in exercises. And 1 radian is equal to pi by 180. 1 degree equals to pi by 180 radian. The fundamental relation is this. Just keep this much in your mind. 180 degree equals to pi radian. This is basic relation which you need to remember. Okay. So now we go to exercises. But before I go to exercises, I forgot to mention this. You might have studied earlier. Just recall, you might have studied probably in 10th standard geometry. If this is a circle with center O, OA, this is OB. So here arc length, let me take L here. The radius, let me take R here. And if this is theta, then you know theta equals to L by R is the standard relation. Right. So we use this also. This is from geometry, remember. It has nothing to do with Trigo, or this is very basic relation. If this arc length is L radian, arc length is L, then this is nothing but the measure theta equals to L radian. So, and if this is radius R, then there is a relation theta equals to L by R. What is theta? That is the measure of this angle. What is R here? Radius. And what is L? That is this arc length, remember. So we use this in the next exercise. So exercise 3.1 now. The first question, if you see, find the radian measure corresponding to the following degree measures. So we are given in form of degrees. We'll convert into radians. Radian means in terms of pi. First question is degree to radian, as you know. So let's take here theta equals to 25 degree. Now we want in terms of radian, that is in terms of pi here. So 25 into pi by 180. So this is a radian here. You know 1 degree equals to pi by 180 radian. No need to write here radian. Once you write pi, it is understood it's in terms of radian. So this will be 5 pi by 36. So we live in this form only. Again, I'm emphasizing no need to write here radian. Once you express in form of pi, it means it is in terms of radian. So 25 degrees same as 5 pi by 36 radian. Let's go to second question. You have theta equals to minus 47 degree, 30 minutes. This minus sign is not important for us. This is important for us. 1 degree equals to 60 minutes. So this is half degree. Minus 47 and half degree. This is a half degree. So this would be minus, I suppose, 47 and half. It would be nothing but the 95 by 2 degree. 47 into 2, which is 94 plus 1, 95 by 2 degree. Now we convert into radian. This is just a simplification. So 95 by 2 into radian. So multiplying with this. Radian means in terms of pi. So pi by 180. Again, 1 degree equals to pi by 180 radian, So I've used this. Now if you simplify, here 36 5s are, and here 19 5s are. So 19 pi by this 36 into 2, so 72. This is the measure of angle in terms of radian. Third one is here 240 degree. Let me call that as theta. So I'll convert in form of radian. So multiplying with this factor here. So pi by 180. It is in form of degree now. So this is 0 will goes away. So here this is nothing but, if you reduce it, it would be just 6 4s are 6 3s are, so it would be 4 pi by 3. So 240 degree, it is same as 4 pi by 3. If you want to see here, it would be like this here. If this is like unit circle, now 240, so it is more than 180. So over here, and this 180 plus 60, so it would be somewhere here like this much. This measure is nothing but, it's a positive, so it is in anti-clockwise direction, this much up to this ray. This is the initial ray, just I'm showing you for your information. This is the initial ray up to this is the final ray. So this is 240 degree, remember. Here up to this it is 180, and then this roughly this is 60. So you have 180 plus 60, so you will get the total here 240, and this is same as 4 pi by 3, right, this much. 260 degrees, 4 pi by 3. So here radian 2 degree, remember. So first angle theta is 11 by 16. This is purely a number, remember. Now we want to convert into degree. 1 radian equals to, this is 1 radian equals to 180 degree by pi, remember. This. So multiplying with this, 11 by 16 into 180 by pi, but this is in form of degree now. 1 radian equals to 180 by pi. You recall this, 180 degree equals to pi. Here I want 1, so take pi over here, so 180 by pi. Just to remember this, if I want 1 degree, take 180 over there. Now usually we put pi equals to 22 by 7, so 11 by 60 equals to 180, 22 by 7 here. So if you simplify this, just simplify this, you will get the 315 by 8 in form of degree. Now if you divide 315 by 8, use calculator, you will get the 39.375 degree. Like usually we reduce this degree to minutes and then seconds. So this will be, as I explained, this is 39 degree. Now this 0.375, it is in degree. I want to convert into minutes. So I'll write 0.375 into 60. Now it is in minutes, remember. So if you do this, you will get, if I do this much here, you will get the 22.5. So I can say that this is 22 minutes. Now again come to this 0.5, this is in form of minutes. I want to convert into seconds, so I'll multiply with 60 again. So obviously this is 30 seconds, so here you will get the 30 seconds. This way you can do. It's just use of calculator. I repeat this, 315 by 8 degree. So if you use calculator, you will get the 39.375 degree. So 39 degree. After decimal point, you are getting 0.375. This is in degree. I want to convert into minutes. You know, 1 degree equals to 60 minutes. So into 60. So I'll get the 22.5. So I'll get the 22 minutes. Now 0.5. Again, I want to reduce into smaller unit. So again, you know, 1 minute equals to 60 seconds. So I'll multiply with 60. So you will get the 30 seconds. Usually we'll reduce up to minutes and then second. This way we convert radian to degree, remember. I'll do one more. You will realize theta equals to -4. Minus sign just indicates that you are moving in clockwise. So you have 4 into this factor, which is 180 degree by pi. Now put the value of pi. So usually we put 22 by 7. 22 by 7. This will be in degree. Now you just simplify. So if you simplify this, you will get minus sign is already there. 2520 by 11 degree. Now use calculator. You will get minus sign as it is 229.090. This is in degree. So you have minus 229 degree, 0.090 multiplied. This is in degree. I want to convert into minutes, so I'll write into 60. So you will get here 5.45, roughly 45 if you do this. So I'll get the 5 seconds here. Now again this much, that is 0.4545. This is in seconds, minutes. I want to convert into seconds, already into 60. So if you do this, you will get roughly 27 point something. So this is 27 seconds. I repeat this portion. Simplify this, 180 by pi to convert into degree. Simplify this, you will get this much. If you do by 11, you will get the 229 point this much, but this is in degree. So 229 degree. After decimal point, we will convert into minutes as I explained. So 0.90 multiplying with 60. So we'll get the 5 point something. So this become 5 minutes. 0.4545 again multiplying with 60 to convert into seconds. So we'll get the 27 roughly. So 27 seconds. So 4 radian is roughly 229 degree, 5 minutes and 27 seconds. Minus sign is not important, that just we copied from the beginning. So next is 5 pi by 3. This is in radian because it is in pi. We want to convert into degree. So 5 pi by 3 into 180 by pi. This is the relation. 1 radian equals to 180 degree by pi. This much we know. Now you just simplify. Pi will get cancelled. This is 60. So we'll get the 300 degree. So here theta is 300. Now question number 3 here. Next main question 3. Question says that a wheel makes 360 revolutions in 1 minute. In 1 minute, total rotations equals to 360. Now the question is how many radian means you are asked indirectly arc length. Does it turn in 1 second? So we need to find how many revolutions in 1 second. So just use this 1 minute 360 revolutions. This is 60 seconds equals to 1 minute equals to 360 revolution. So 1 second, how many revolutions here? So number of revolutions equals to 360 into 1 by 60, you know, triple ratio. So this is 6. So in 1 second, 6 revolutions. 1 second, your revolutions equals to 6. I repeat this portion. This is given to you in the question itself. 1 minute 360 rotations. Revolutions means rotation taken by a wheel. Question is, first, how many revolutions in 1 second? 1 minute means 60 seconds. So in 60 seconds 360 revolution. So in 1 second, how many revolutions? By triple ratio, these into this upon 60. So 1 second equals to 6 revolution. Now go back to definition of radian. You are asked for how much radian measurement of an angle is taken by this wheel. So radian measure. Now if I consider like this, if I start with this, for example, if I take 1 revolution, 2 pi radian, you know this. Second revolution, 4 pi radian. Third revolution, 6 pi radian. Fifth revolution, 8 pi, and 6, 12 pi. So 1 revolution equals to 2 pi radian, and therefore 6 revolution equals to 2 pi into 6 equals to 12 pi radian. I hope this is clear to you. First, what you did, from 60 seconds you counted how many revolution in 1 second. So 6 revolutions. Now we have understood very well that in 1 revolution 2 pi radian, that 1 rotation around the unit circle, this arc length, that is the circumference of the unit circle, from the beginning it is 2 pi. 1 rotation 2 pi, 6 rotation 2 pi into 6, that is 12 pi radian. Next question, you have a circle here, the center O. Find the degree measure of an angle subtended at the center of a circle, radius 100. So this is 100, r equals to 100, by an arc length of 22 centimeters. So this is 22, L equals to 22, and you are asked to find theta. Question is, here L is 22 centimeter. Radius in the question itself you are given 100 centimeter. The question is get theta. So theta is, of course, this is 22. So we use here theta equals to L by R formula, This is the standard formula, theta equals to L by R. So theta equals to L is 22, radian is 100 here. So theta equals to here 11 by 50. Now here in the question, this is a radian measurement of an angle. but in the question you are asked for degree measurement of an angle, if you see. So now this is nothing but your question number 2, just to convert this one into degree. Your question is over if it is asked in radian, but you want to convert into degree. So you know here 11 by 50 into, you know what is to be done here. We want to convert into degree, so 180 degree by pi, then put just value of pi. So 11 by 50 into 180 degree, this 22 by 7. So I'll write into 7 here and degree. Now we just simplify this. This is 2, this is here 90, 0 0 will get cancelled. So you are just getting 9 7 is 63 by 5 degree. Now we use just calculator here. So if you do 63 by 5, you will get the 12.6 here, 12.6 degree. So we'll get the 12 degree, 0.6 degree. I'll convert into minutes. So I'll write here 0.6 into 60. So you will get the roughly 36 minutes. If you want, you can convert further into seconds also, but it will do up to this. So 12 degree and 36 minutes, that is the measure of this angle. I repeat them, we have just used theta equals to L by R formula. If you are asked in radian, your sum is over here. This is the measure of an angle theta subtended by this arc at the center in form of radian, but in the question itself you are asked in form of degree. So this is just nothing but, this portion is nothing but repetition of question number 2. That's what we did in main question 2, from radian to degree. So question number 6, we have 2 circles here. In this question, having same arc length, so this is one arc, let me call L1, this is another arc, let me call L2, this is a center, this is a center. Now these 2 angles you are given, let me call theta 1 as, for example, 60 degree. Here theta 2 you are given 75 degree, this is theta 2. Radius R1, radius R2. The question is, find the ratio of the radii, R1 by R2, you want this. And in the question you are also given that same lengths, so arc lengths are same here. So you are given L1 equals to L2, this much is given, this we want. So use theta 1 equals to L1 by R1, theta 2 equals to L2 by R2. So L1 equals to theta 1 R1, that is equals to theta 2 R2, because here L1 equals to L2. What is theta 1? 60 degree into R1. What is theta 2? 75 degree into R2. You want ratio of the radii, this is the question, R1 by R2. So 75 degree by 60 degree. So here R1 by R2, that is equals to, if you just, here degrees are same, so you will get here 5 by R1 down 75, yes, you will get here 5 by 4. Next question is, find the angle in radian. So we find angle in radian. This is a question, angle in radian. You are not asked for degree, so just leave in form of number, through which we have a simple pendulum here. So it's like this. This is a fixed point O, so it's like a radius. This is a pendulum that swings. So this swings like this. Like this. Now in the first sub-question, there are 3 sub-questions. The first sub-question, that simple pendulum having the length 75 centimeters. So this is a 75 centimeters. So this looks like a radius, you can imagine. This arc length, this is the tip of this simple pendulum here. So this tip describes an arc length first 10 centimeter here. Question is, you get this theta here. This is the radius, this is the arc length. So we use theta equals